we're going to work on an ALEKS problem that deals with using the general properties of equilibrium. In this ALEKS question, they've given us a balanced chemical equation with an equilibrium constant, and they want us to answer some questions. Let's remember that the equilibrium constant is the concentration of the products raised to the power of coefficient over the concentration of the reactants raised to the power of its coefficients. So in this balanced equation, K would equal to the concentration of the products raised to the power of its coefficients over the concentration of the reactants raised to the power of their coefficients. And they tell us that K is equal to 8.0 times 10 to the negative 5. So if K is less than 0.1, that would suggest that the reactants is a large number mathematically, and that their equilibrium will favor the reactant side. So if it favors the reactant side, it will make less of the product side. So it would make more reactants and less products. So in this first part of the question, they want us to determine the composition of the mixture in the vessel at equilibrium. They want us to say what will happen if this equilibrium constant is less than 0.1, which it is. So that means we would make more reactants, less product. So of our options here, that means we will make more Cl2, CHCl3, and very little HCl, CCl4. So this would be our answer. Okay, in the next question, they want us to solve for the equilibrium constant of the following reaction. And if we examine this chemical equilibrium, it is actually the flip, the inverse of the given reaction. So in this given reaction, we have Cl2 reacting with CHCl3 to yield HCl and CCl4. The question is asking us about the flip. They're asking us what will happen to the equilibrium constant if we had HCl plus CCl4 to make Cl2 and CHCl3. So it is actually the same reaction but flipped. So if we would call this the original reaction the forward reaction, then basically they're asking us for the reverse reaction. So the reverse equilibrium constant is just the inverse of the forward reaction. So all I have to do is say 1 divided by 8.0 times 10 to the negative 5. And our final answer would have 2 sig figs. So 1.3 times 10 to the 4th. Remember that equilibrium constant has no units. All right, in the third question, they want us to determine the equilibrium constant of the following balanced equation. So we know that the equilibrium constant is products, the concentration of products raised to the power of its coefficients over the reactants raised to the power of its coefficients. So if I take a look, and let's just call this K2 just to distinguish it from the other Ks. So if we take a look at K2 and compare it to our forward reaction, KF, we see that it's almost very similar. It's the products are HCl, CCl4, and the reactants are the same, Cl2, CH, Cl3. The only difference is the coefficients. All of the powers in KF are to the power of 1. And all of the powers in K2 are to the power of 2. So K2 is going to be KF raised to the power of 2. So we're just going to do that. Raise it to the power of 2. So this would equal to 6.4 times 10 to the negative 9. Let's take a look at the next example. So in this example, they've given us a balanced chemical equation with an equilibrium constant. I want to remind myself that the equilibrium constant is the concentration of the products raised to the power of its coefficients over the concentration of the reactants raised to the power of its coefficients. I also want to go ahead and write down the equilibrium constant expression. So K is equal to the concentration of NO raised to the power of 2 over the concentration of N2 raised to the power of 1 times the concentration of O2 raised to the power of 1. And in this example, K is 387. So that means K is greater than 10. So in chemistry, that just means for this particular problem that this is considered a large number. So mathematically, when we have a fraction, for us to get a large number, that would suggest that there is more products than reactants, more numerator than denominator. So when our K is larger than 10, the reaction favors the product side. So it's going to make more NO and less N2 in O2. So take a look at our first question. They're asking us about the composition of the mixture in this vessel with the equilibrium constant of 387. So we're going to make more NO and very little N2O2. So this option would be the best option for us here. In the second part, they're asking us for the equilibrium constant of the following chemical equilibrium. We're going to examine our original chemical equation, and we see that what they're asking about is the inverse. So the reverse reaction is just the inverse of the forward reaction, and we're going to call the original reaction forward. So Kr is equal to 1 over 387. So that makes K equal to 0.00258. All right, now they want us to figure out the equilibrium constant of the following chemical equation. So I'm going to remind myself, and I'm going to call this K2 just to distinguish between the other Ks. It is the concentration of the products raised to the power of the coefficient over the concentration of the reactants raised to the power of its coefficients. So I do have my Kf. I know that Kf is 387, and they want us to solve for K2. I take a look at mathematically what's different. I have the same products, I have the same reactants, except that the powers are a multiple of 3. So K2 is really Kf to the power of 3. So K2 is equal to 387 raised to the power of 3. So that means K2 is equal to 5.80 times 10 to the 7th. And remember that equilibrium constant has no units. Good luck and keep practicing.